Good afternoon, folks. Here's our review problem for today. We have a window washer who is pushing his scrub brush up a vertical window at a constant speed by applying a force as shown in the picture below by this red F arrow. The brush weighs 15.0 newtons and the coefficient of kinetic friction is 0.150. We are asked to calculate, for part A, the magnitude of the force F, and for part B, the normal force exerted by the window on the brush. Before we move on, pay very close attention to the following. The brush is only moving up a vertical window, and it's doing so at a constant speed. If you're only moving up on a vertical window, that implies that the horizontal motion must be 0, and a constant speed implies that the acceleration must be 0 as well, which we'll see later. Let's jump into the free body diagram. We have our familiar x and y pointing in the directions that we've seen before, and here are the following forces that we have to deal with. We have the weight of the brush pulling directly down. We have the force of the window pushing back on the brush, which is the normal force, which points to the right. We have the applied force of the window washer pointing up into the left, as you can see here. And we were also explicitly told in the problem description about kinetic friction. And since the direction of motion of the brush is moving up, kinetic friction must act in the direction opposite to that motion, which is pointing down. The only vector that we have to break into components is the applied force, because everything else lies along an axis. So let's do that for F. We'll include the angle, the 53.1 degrees, and we can also include the arrows for the components. Rather than writing 53.1 degrees everywhere, for the time being, I'm just going to call that theta. So we have F cosine theta, F sine theta, and those act at right angles to each other. And that's it. Those are all the forces acting on the brush in the problem as it moves up the window at a constant velocity. Now we're set to jump into the realm of Newton's second law. Let's go ahead and do that. We'll move all this off to the side and we'll bring F equals ma into the picture. Starting with the x direction, we have the normal force, the force of the window pushing back on the brush. That acts in the plus x direction, so that's our positive term here. And then out of the F vector here, the component that points to the left is F cosine theta, so that's negative. We mentioned earlier that the brush is only moving up, so there's only vertical motion, and there's no horizontal motion, so the sum of forces has to be equal to 0. There's no net acceleration in the x direction. So that means we can algebraically move this term over to the other side and conclude, hey, the normal force is equal to F cosine theta. There's nothing else we can do in this direction, so let's hop over to the sum of forces in the y direction. We have the component of F pointing upwards here, F sine theta, so that's our positive term. And the two other terms that are negative are the kinetic friction and the weight, which point directly downward. Recall the velocity as the brush moves up on the vertical window is constant, so the acceleration is 0 in that direction. So that's why this is 0 here. We can exchange the force of kinetic friction for the coefficient of kinetic friction multiplied by the normal force that we're used to. So that will be that next step there. And we can also replace our expression for the normal force for f cosine theta and bring that over here. Remember, the goal for part A is to solve for the magnitude of the applied force F. So if we bring this over to the other side and move the weight over like this, here's what that next line looks like. Since I have F in both terms, I'm going to factor them out, and so I'm left with F multiplied by everything here in the parentheses. I can divide both sides of this expression by everything in the parentheses, and that gives me my expression for the magnitude of the applied force F. It's in terms of everything that we have already. We were given W. We were given theta. That's 53.1. We were given mu sub k. We know everything. So let's plug it in and finish off part A. I'll bring this expression over to a fresh page right here. And if we plug in the values that we were given, that's what this looks like here. If you enter this into your calculator, you should get a value which is approximately similar to this one. And we have to truncate it to 3 significant figures based on all the other numbers that we were given. And that leads to this number, 21.1 newtons. That is the answer to part A, and we are now finished. What about part B? So for part B, we had to solve for the normal force, right? The force that the window pushes back on the brush. We just got F, we just solved for that, and we already know theta. So all we have to do is just plug those values in here, like this, and this is what we get. Or you should get something approximately similar to this, at least. And truncating to 3 significant figures, we get 12.7 newtons, and that is the answer to part B. If we put them all together on the solution card, here's what we get. Thanks for watching.